Pretty good. All right, the first thing I notice when I look at this is over up here, if I look at the left-hand side, I see a cube. And then on the bottom, there's a lot of the same thing going on. Now, what I'm thinking is, and one of the reasons I'm kind of thinking to go this way is right now, in Algebra 2, we just got through factoring cubes. And that's a cube that would factor on the top. And what I also notice about it is on the bottom, this tangent theta minus 1 is one of the factors of that cube. So if I could factor it out, I might get something that I could work with that I could turn into the right-hand side. So that's kind of the approach I'm going to take. Now, I don't know if you remember when you factor a cube. Let me write the factoring pattern on the board. Okay, so if I have tangent theta, or I'm just going to say theta because I don't want to even worry about what I think it's an alpha. Tangent alpha cubed minus 1. I could rewrite that as tangent alpha, cubed minus 1 cubed is how I'm going to look at it, so I can use that factoring pattern. Okay, so if I factor it, I'm going to have to go to the next line. There will not be enough room. If you follow that factoring pattern on the board, I take the two things and I subtract them. Okay, then I take the first term, which is tangent theta, I square it. I multiply the two things together, so 1 times tangent alpha is tangent alpha. Because I had a minus sign in the first factor, I'll write it in red, plus sign here, and that's because I had a minus sign right there. I'll kind of highlight them so you can see what I'm talking about. And then you've got the 1, you've got to square the 1, so it's plus 1 squared, which is just 1, all over tangent alpha minus 1. And do you see now why I kind of wanted to do that, right? Because these are going to cancel out right here, aren't they? Look what we have. So since there's 4 terms, we're going to factor by grouping, and if you don't remember, we'll kind of go through how you do that again. What you do is you take the first 2 terms and you group them together, and you take the second 2 terms and you group them together. And what we're going to do is in each of those sets of terms, we're going to look for a GCF to pull out, and a lot of times what happens is when you pull that GCF out, magic happens, okay? Magical things happen. Okay, now I'm kind of noticing that, this is what I'm thinking I'm going to do, but I'm looking down there going, you know what? There's nothing that's going to come out of that second set of terms. But under that blue line that I drew, do you see that that's negative sine squared x minus cosine squared x? One thing I kind of know that's going to happen there is if I pull a negative 1 out of there, I'm going to have sine squared x plus cosine squared x. That's going to be 1, isn't it? Because don't we have that identity that says sine squared x plus cosine squared x is 1? So we may try this factoring by grouping. It may get us somewhere, it might not. This is all I know to do, honestly, so we're just going to go for it. If you look at the green thing, there is a GCF there. There is a 2 in both terms. There's a secant squared x in both terms, right? So let's at least try to factor by grouping, because maybe even just by trying this process, we're going to get somewhere, even if we do something else in the end. If I have 2 secant squared x and I divide out 2 secant squared x, anything divided by itself is 1, okay? Then we write down our subtraction sign. What would be left out of that second term? Yeah, just this right here. That's the only thing left, so it's going to be sine squared x. Okay, now let's go to the second term. The factoring by grouping is not going to flesh out for me, but it's going to get me somewhere. Just trying it's going to get me somewhere. It's the only thing I need to try. What can I divide out of the negative sine squared x minus cosine squared x? There's no factors in common, but I could divide a negative 1 out and get rid of the subtraction signs, and that's going to be helpful. Come back. So I'm going to divide a negative 1 out. I'm going to say that's the GCF, and what would be left, when you divide by negative, doesn't it just change the signs on everything on the inside? I mean, anytime you divide by negative, you're switching the sign on something. Positive divided by negative is a negative, and negative divided by negative is a positive. If I divide a negative out, it just changes the sign on both of those terms. Now, Usually in factoring by grouping, what happens is that this right here and that this right here are the same thing. And that's where you usually kind of get going. They're not the same thing, but they both have something to do with an identity. So let me simplify. Again, I don't know what I'm doing here. I'm just trying stuff, right? I recognize that sine squared x plus cosine squared x down here on the end, that's equal to 1. That's that identity, isn't it? The most basic one that we first learned. So this is going to become minus 1 times 1. I'm going to replace all this right here with a 1 because it's equal to 1. So I know I can do that. I'm not quite sure up here what to do, except that I do notice that inside this parentheses, if sine squared x plus cosine squared x, let me come down here, maybe I can cram it in. Sine squared x plus cosine squared x is 1. Then if I wanted to find out what 1 minus sine squared x is, if I subtract sine squared from each side of this identity, just to try to play with it a little bit, wouldn't 1 minus sine squared x be equal to cosine squared x? So let me replace that, and I think I know what's going to happen now. Okay, so 1 minus sine squared x is equal to cosine squared x. So let's write cosine squared x in here. We'll replace it with an equal thing. How's that going to help me? Do you kind of see what might happen now? You ready to see where this might go? What do you know about secant and cosine? How are they related to each other? Yeah, they're reciprocals, aren't they? So they're going to end up canceling out. If you wanted to write it this way, secant squared, you could replace it. Isn't secant 1 over the cosine? So instead of writing secant squared x, I could replace it with 1 over cosine squared x. You could just go, they cancel each other out. That's, but if you want to write it in, this is how you could write it in. And then you got cosine squared x minus 1. Just keeping up with that minus 1 on the bottom. And the cosine squareds cancel out. And again, we could have noticed that secant squared and cosine squared canceled out. And we could have put a 1 in there to show that they canceled out. But now what I have is 2 times 1 minus 1. What's 2 times 1? 2. Minus 1 is 1. We got it, right? We're there. So I'm going to draw a right triangle because I don't know if you remember anything, but we've worked some problems that have had these inverse trig functions and a trig function kind of grouped together like that. I think we actually had some on our last test that we did, or I can't even remember what, but anyway, we've had some of these in previous sections. And one of the strategies to figuring these out is you got to draw a right triangle, and you're trying to fill in the sides that you don't know, okay? So if you remember what we do, when usually we had numbers here like square root of 3 over 2 or something instead of x minus 1 over 4. But our strategy was then is we fill out our right triangle. So if what this is telling me, this part right here, remember I start on the inside, what's telling me is I have an angle. Let me draw it over here. And that angle has a sine value of x minus 1 over 4. Well, you remember the sine function is opposite over hypotenuse, right? So just kind of right up there. Doesn't that mean my hypotenuse is going to be 4 and the opposite side of that angle is going to be x minus 1, right? Can I figure out that other side? I can. I'd have to use the Pythagorean theorem. Let me call it, I'm just going to call it A so it doesn't have an X in it because it's just going to get really complicated looking. A squared plus x minus 1 squared is going to be equal to 4 squared. That's just the Pythagorean theorem, a squared plus b squared is c squared, right? All right, let me see how they, let's just go ahead and say, I could multiply out x minus 1 squared, but I kind of notice if you look at your answer on the right, it's already it's still grouped that way, isn't it? So I'm not going to multiply it out. That was something I'm kind of thinking maybe I might need to do, but I don't know. And since it's all grouped up over there on the right-hand side, I'm going to just say let's just subtract x minus 1 squared from both sides. So that a squared is 16 minus x minus 1 squared. But I don't want to know what a squared is. I want to know what a is, so I'm going to square root both sides, and this is going to be extremely ugly. But this a right here, that side is going to be equal to this expression. I'm just going to draw a line up to it because I know that I can't rewrite it in that space without it looking like garbage, okay? Okay, so what I'm kind of doing, I hadn't really separated it out yet. I've taken the left-hand side, and I'm trying to make it look like the right-hand side. Do you remember when we did problems like this, we might have had a problem tangent of the inverse sine of square root of 3 over 2, that all we used this inside part for was to draw a right triangle. And now what I want to do is think, okay, now what I want is the tangent of this angle over here. You know, and I use that inside expression to kind of represent the angle, the right triangle the angle's in. So now all I need to do is just take the tangent of that angle. And if you remember the tangent of that angle, tangent is the opposite over adjacent, isn't it? That's TOA in SOHCAHTOA. So the expression that's going to represent the opposite side is going to be x minus 1 on top. And what's the adjacent side going to be?
16 minus.
Yeah, that mess that I circled in purple, and ta-da, we're done already, aren't we? Okay, so this is a lot like things you've done before that had easier expressions in them. We're using the same techniques, it's just that it looks uglier because it's just a bunch of algebra garbage, right? So we're there already. All we had to do was draw that right triangle, find the other side, and then take the tangent of that angle. Taking the tangent just means writing that fraction, and then ta-da, it's all there.